Okay then, let's do our next maths lesson. So I am well aware that your first lesson yesterday on equivalent fractions might have been a new concept, and it's something tricky to get your head around. So hopefully I tried my best to explain what equivalence is. And that's why I kind of wanted to give you just a chance to explore it, either go back through the video again or have a go practically making some of your own fractions using paper, and then seeing whether you can understand that two different fractions can mean the same thing. So basically, when we're talking about equivalence, all we're talking about is that equal sign. Equivalence is another word for equal, which is the same as. So two fractions need to be the same. And I gave us a little demo yesterday when we talked about, we know that two fractions can be the same in the sense that when the denominator and the numerator are the same, that's our whole again. Okay. So the whole is all of our parts, and a fraction is just part of the whole, but when we've got all our parts together, we've got the same. So that 2 halves is the same as 1 whole. Yeah, so when we're saying that one, think of it as 1 whole. So it can be a number, but for this instance, it's just going to be probably shapes to begin with. And then we kind of moved on to, well, let's keep the whole the same. Let's keep my square the same. And maybe some of you did this with paper. And let's split it into quarters this time. Yeah, imagine I've still got that line in there. And I shaded in 2 of my quarters. And hopefully you've seen that 2 quarters is the same as half of my my original whole. So I can say that 2 quarters is the same as, is equivalent to 1 half. And then we looked at another problem that maybe you've seen, that different fractions can also be equivalent as well. Let's see if that's good. Right. I had that problem there where it was 2/8. But if I move my 8 together, I can also get that quarter again. So we could say that 2/8 is equivalent, is the same as 1 quarter. And there are patterns that you can see here. So what's the pattern there? We'll have a half or doubles, and maybe that works for the other fractions as well. We'll have to see as we go through and explore what equivalent means. And I left you with that little challenge there. So what would be a half? So go back, and the highlighter is quite good for this because you can see shade in your half. Oh. Okay, there's my half, isn't it? And then shade in my 8. So there's 1 there, 2, 3, 4. 4/8 is the same as 1 half. And then we're going to look at thirds in a bit. But that's hopefully, we gave you a bit of background yesterday. I'm going to go through a lesson today from Math No Problem with some worksheets for you to do. So again, have a go through some of these if you want to just do a little bit of a maths warm-up, but we're just going to get straight cracking onto fractions today. We're going to go through that in a bit. I just wanted to draw your attention to this website here, White Rose Maths. And if you go into the scheme of work and primary section, you can go into year 3 go on to the fractions part. And in here is everything that we should have been doing already. So we can do this. You should be able to count in tenths in lots of different ways, either in a counting stick, so that would be 1/10, 2/10, 3/10. Maybe using a tens frame, you can count in tenths. It's a little bit of a challenge. So if you can complete that, remember you can copy these out into your book. Lots of counting. Let's see if I can find any. Let's go on to fractions of amounts, and we're not doing fractions of amounts, we're doing just equivalent, so we'll probably leave that and we'll go on to our lesson today. So we're looking at equivalent fractions, finding equivalents, and we know that that means we're just finding things that are equal, things that are the same. So that leads us nicely onto our in focus task. So you've got this, let's call it a chocolate bar, or for the time being, with maybe some caramel pattern on the top, and the whole chocolate bar is your whole, obviously, and he is split it into quarters, so each part is a fourth, remember, or a quarter per se. You can pause the video if you want to have a go about me jibber jabbering, or skip it if you want to carry on, if you've got it. Okay, so this is how I would tackle the problem. So I've make sure I check my understanding. I know I can see what he's done here. He split the whole into 4 equal parts, so each part is a quarter. And he's going to get one of those parts. So he's got 1/4, and there's going to be 3/4 left over. Is it possible then to get more parts but keep the whole the same? We should agree with this statement. We should know that it is possible, but how can we do that? How can I split this further but without changing the whole? So I'm not going to be adding any bits. No. I need to, how can I edit this? What do you think? There's a few ways you could do it. Right then. We'll go through the lesson now, but I'll just show you on here how my brain's focusing on. Some people like listening to it, some people like watching it, some people like having a go. So hopefully you found lots of different ways of splitting that up, but you know that, like you did with your piece of paper, if you can split it up again by halving each section. So I think this is how they're going to do it, but they're going to take each quarter and maybe split it again, and the patterns help you. So you can see here that I've not changed the whole, not done anything to the whole, I haven't added any bits or taken any things away, but I've changed the parts. I'll change the fraction. So originally I had quarters, but now I've got 1, 2, 3, 4, 5, 6, 7, 8. And now the red bit is 8. And 1/4, what is 1/4? How many 8s is that? Another, hopefully if you've really got this, there's another way of splitting it. And if you've done this, then you really are on the way with equivalent fractions. So there's the whole again, there's the quarters. How about if I do the line straight down the middle? Yeah, I'm going to fold it, cut them that way. 1, 2, 3, 4, 5, 6. Still got 8. It's just another way of representing them. There's another way as well. You could split each quarter that way, as long as your parts are what? As long as they're equal parts. Yeah, you could do it like this if you wanted to. Yeah, the parts are the same. If you rotated them, they'd still get 8s. If you split those 8s again, what would you get? Now we're going far more detailed. Right. Enough of me. Let's have a look at the Let's Learn section, if my explanation wasn't good enough. This first bit, this would be absolutely fine. Each part is a quarter, he's got a quarter, yes? But then they cut those quarters again into 2 more equal parts, so it's not going to be 2 quarters, is it? No, no, no. It's not going to be 2 quarters because I haven't split it into 4 equal parts now, but 1, 2, 3, 4, 5, 6, 7, 8. So each quarter is 2, 8. Let's change that pen, that's annoying, isn't it? We could cut each one again. So now I would have 1, 2, 3, 4 equal parts, and this I could do. I have to cut this one into 4 equal parts. It's hard to do on the line, but you get the idea. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4/16 is the same as 1/4. The part hasn't changed. That part there, that quarter, is exactly the same as the original quarter. I'm just making the parts smaller and smaller and smaller. So you'll notice what happens when the parts get smaller. What happens to the denominator? The denominator gets bigger. So that's one thing to kind of get your head around. When you see a big denominator, yeah, the bigger the number, the bigger the denominator, the smaller the part. That's another misconception. Try and get your head around it. It is tricky, but as long as you know that all you're dealing with is just parts of your whole, you should be fine. Can you cut then the quarters to get 12 equal parts? Now this is where your times table knowledge helps, because if you know you've got 4 equal parts here, you'll know how much each part needs to be split into in order to get 12. What's the relationship between 4 and 12 in your times tables? You should see, or hopefully see the pattern, that if I've got 4 parts but I want to get 12, I need to split each into 3, because 4 times 3 is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And how many 12ths would be equal to 1/4? How many 12ths are equal to 1/4? 3. So we've done loads there. We've shown that there's at least 3 or 4 different ways, 3 or 4 different fractions that also are the same as a quarter. We don't say 1/4, we say 1/4. 1/4 is equivalent to 2/8, which is also the same as 3/12. We also did 4/16. Yeah, so that's There's loads of, you could say that 2/8 is the same as 3/12. You could say 3/12 is the same as 1/4. 1/4 is the same as 4/16. And maybe you'll notice the patterns. Yeah, there are, if you are familiar with your times tables, you will see a lot of logic between your multiplication division skills as well as fractions, because you're dividing your parts into, you're dividing your whole into equal parts, which is just what dividing is. That's why this fraction line can also be seen as a division. So this fraction here, this 3/12, I've split my whole into 12 equal parts. The whole has not changed throughout the whole entire question, and I have 3 of my parts, yeah, which is the same as the quarter. So then you might get the challenge question out of this would be, which would you rather? Some questions like to say, would you rather 1/4 or 3/12? And you'll initially think, well, I want 3/12. 12 is a big number. I've got 3 of those 12s. I want 3/12. But the trick there, what's the trick? They're the same, aren't they? You get exactly the same. So you might have a question, would I rather 1/2? Yeah, so hopefully if I say 1/2, you've seen that that's the half, 2/4. Do I want 1/2 or 3/12? One half or 3/12? Which would you rather if you were sharing this chocolate bar? Would you rather 1/2 or would you rather 3/12? You might initially think, well, 3/12, that's 12 of things. 3, that's massive. 1/2, 1/2, 1/2. No, I'm going to have 3/12. But you'd be wrong, because half is much bigger than 3/12. Hopefully that helps a little bit. I'll show it a little bit on the guided practice. Do pause and have a go if you're feeling confident already. So there's my whole, and the whole is not going to change throughout the whole entire question. I've now split into halves. Right, I want to know the equivalent fraction to quarters. So I need to now split each half in half again. So I've got 1, 2, 3, 4 equal parts, and how many of those quarters equal a half? You guys have a go. Now I want 6. How can I split this into 6 equal parts? Now it's hard to do. With your pen, you should know that you're not going to split half and half again, because that's going to give you 8ths. So we need to split each half into 3. So even though I've crossed that boundary here, yeah, this is still one part here, even though I've crossed. So I've split my whole into 6 equal parts, roughly. 1, 2, 3. 1, 2, 3. Oh, there is a part here, isn't there? I was saying, even though I've crossed that boundary, that's part and that's a part. 1, 2, 3, 4, 5, 6. My apologies there, my mistake. So I've got 1, 2, 3, 4, 5, 6. I've got my 6 equal parts. A half is how many 6? Well, it's 3 6. And hopefully you'll notice some of the patterns that are emerging. So you know a half, okay, is something divided into two, so to two equal parts. So if I've got 6, half of my 6 parts is going to be 3 of them. Half of my 4 parts is 2 of them. If you understand that pattern, what would be half? 1/2 is equal to how many 12ths? Well, if I've got my 12 equal parts, what's half of my 12 equal parts? 6 parts. You could do it into 24ths. Half of is the same as how many 24ths? Well, what's half of my 24ths? Yeah, so there are loads of number patterns that start to emerge that are linked to your times tables and just your common number knowledge. Let's try this one then. Thirds. So there's my whole, and there's a third. 1/3 is the same as 2 something. So I've got to split each of my thirds into 2, because I know that, because my numerator is 2, and I know that it's equivalent to a third, I know straight away that I've got to get this third and make 2 equal parts from it. So then I'm just going to do the same to all my other parts, and that will give me my denominator, won't it? 1, 2, 3, 4, 5, 6. So here, how many parts are you going to split the third into now? So there's a third again, because you know that's a third, so that's got to be a third. How many parts are you going to split that third into? Should have done it into 3. And then you've got to do the same for all, because all the parts have to be equal. Then that should give you a denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, you could shade those in if you wanted to make it really clear. Yeah, I haven't done anything to my whole. That bar has stayed the same. Split it into thirds, and then I split my thirds into 6, and then I split my thirds into ninths. Yeah, and all of those are the same. You see by the picture, they're all the same, so they've all got to be equivalent to a third. Yeah, I could also extend that and do 1/3 is the same as 2/6, which is the same as 3/9. I have to split my ninths again. And there's a big fraction wall that I'll introduce probably tomorrow when you guys have had a bit of a practice with this. So yeah, if that doesn't make sense, go back over it or pause it or have a go or ask an adult to maybe see if they can explain it better than I can. But I'll throw up some questions for you. Again, I'll put these on the video and I'll put them on the Google Drive, but you should be able to just work from the video. I'll try and put another one on because there's not a lot of questions here, and it does these things just take practice. I might get you to fill in your own fraction wall maybe. So there's question 1. 1/4 is how many 8ths? You should see that's your 8ths. And they've put that block there whole to show you that I haven't done anything to the whole, it's just the parts that are getting smaller. And then we have fifths this time. I've split my whole into fifths. I could split my whole into any fraction, but fifths is the same as how many tenths? Well, it's not 1/5, now it's 3/5. You can pause the video if you want to have a go. Right then, so I'll put that on the Google Drive, but you can have a go yourself on the screen. It's not a lot, and I appreciate you might be thinking, well, that's easy. There's 1, 2, 3, 5 questions. I can do that. Bish bash bosh. It's a really really new and complex idea to get your head around. So next two lessons are I can probably put into one if people are getting this. However, I don't want to rush if this is a complete alien concept to you. If this is a new idea and you can't understand it. So I might put another worksheet alongside this if you want to have a bit extra. I might just do some revision of adding fractions. But I would suggest just really get your head around this. Maybe go back to your foldings of paper, maybe see if you can do it different ways. Can I split my thirds, and what would be, you can make it harder yourself. So let's change the whole. So it's the whole is the same as, we should know that is 3/3. But what about here? What about 3/4? Yeah, 3/4 is the same as how many eighths? Or 6/12 is the same as what? Look at all the different combinations that you can get. See if you can make a long line of equivalents. So you could have 1/4 is the same as 2/8 is the same as 3/12. Can you maybe extend this? What else? What other fractions can I get out of thirds and sixths? Because can I get quarters? Does quarters work in this one? If I split it into thirds, can I get quarters? Can a third be equivalent to a quarter? These are the sort of kind of challenge questions you can ask yourself before we move on. So yeah, if you think it's too easy, absolutely fantastic. Have a look at maybe finding other fractions that are equivalent, or for this one specifically, the challenge would be, can you get quarters? Is a third or a sixth? Can I get sixths to equal a quarter? If I split that whole, I'll give you a clue. Can I split that whole into quarters? Can I get thirds? Maybe, maybe not. I'll leave it there. Trying to do little shorter lessons because apparently people, it's too much for little brains. But I'm sure if you've got it, you'll whiz through this and you'll be having a lovely rest of your day. Keep an eye out for a surprise video that I'm going to do later on in the week, hopefully to lift people's spirits up a little bit. That's just a little sneak preview. But I will see you next time. Have fun using your equivalent knowledge and finding out different fractions. See you later.